Hi, and welcome back. It's time. I'm finally going to tackle the big one. Analog summing. Is this the secret magic ingredient that's missing from your in-the-box mixes? Or is it just a clever way to force you into buying expensive summing mixers and multi-channel interfaces? I'm going to start by explaining my starting position. I confess, I've long been sceptical of the claims that analog summing is better. Let me explain why. First of all, I consider digital summing to be perfect. In a modern floating point DAW, we have more headroom than we can ever possibly need, a noise floor so low that we can disregard it completely, and totally linear distortion-free behaviour in between. If I add signal A to signal B to create a combined signal C, I can then subtract signal B from signal C to recover signal A. And it's perfect. Yes, I know, floating point errors. That just means a noise floor low enough to make analog equipment designers weep. For our purposes as mix engineers, it's perfect. And really, why would it not be? Summing is literally just adding up numbers. Computers are pretty good at that. If they weren't, we would have bigger problems than a shitty mix. So okay, digital summing is perfect. But mathematically perfect doesn't always mean the best sound. This should be no surprise in a world that contains tape emulation plugins. Perhaps analog summing is imperfect in subjectively desirable ways. Let's consider for a moment what those ways could be. Perhaps the summing imparts a change in frequency response, like in EQ. That would, of course, result in a genuine difference in sound. But if that's all it's doing, there's no reason for it to be summing your signals. You could sum them in the box, then run that stereo mix through the analog unit and get the same result. Okay, so what about nonlinearities? Perhaps there are transformers on the outputs of the summing box. Or perhaps it's a passive box and you're then boosting the output with colourful preamps. Again, this will surely change the sound. But again, why does the summing need to be analog in that case? You could patch your digitally summed mix through the same transformers or colourful preamps and get the same result. Lastly, what if the nonlinearities are on the input stage of the summing box? Perhaps each input gets its own transformer, so each channel is saturated separately. This will certainly sound different from the digital mix. And passing that digital mix through the input transformers won't be the same in that case, as there'll be loads of intermodulation between channels that wasn't there before. But while this is the most convincing argument in favour of an analog summing setup so far, it still doesn't actually justify the summing part. You could use your extra I/O to have colourful analog boxes inserted on channels or subgroups within your mix, and get a similar multi-channel saturation effect, with the added bonus that those boxes might actually be doing useful stuff like compression or EQ as well. To look at it from a slightly different angle, I find it notable that Waves have a plugin designed to do non-linear summing, which doesn't actually do any summing at all. There are two possible ways we could interpret this. If you're very cynical, you could say that the marketing department noticed the trend for summing boxes and wanted to jump on it, and didn't care that summing is beyond the scope of a plugin, so they just modelled some saturation instead. The much less cynical explanation still starts with the marketing department, because this is the real world after all. But the plugin developers then genuinely analysed exactly what the difference was, and concluded that it just boils down to saturation, either on the inputs or outputs. Hence, an analog summing plugin doesn't actually need to do the summing. I've honestly always leaned towards the less cynical explanation, partly because what else is there? I don't believe in magic. If it's not changing the frequency response or adding harmonics, what exactly is it doing? Now obviously, there are lots of analog versus digital summing comparisons available here on YouTube. Well, I assume so. Honestly, I haven't checked them all. But every comparison I have seen has made some kind of error that's left me unconvinced by the results. Obviously, there are basic errors, such as failing to level match examples. And we all know about pan laws and how they can trip you up, right? Actually, an easy way to sidestep this issue is to run all your signals out as stereo pairs and preserve your DAW panning. I believe many people do use their boxes in this way. But even so, you need to be careful with all your gains. You can't assume that every channel of the summing box will have identical gain, so you need to calibrate this carefully to make sure your mix balance doesn't change. That's not going to matter when you're mixing in earnest, but if you're trying to create a meaningful A-B comparison, it's absolutely critical. Finally, even if all the above are done correctly, every comparison I've seen has made the following mistake. The analog summed version, coloured with whatever transformers and maybe tubes are in the mixer, is compared against a digital version with no such colour applied. And of course the analog version usually sounds richer, warmer, clearer. Insert all the usual adjectives we use to describe the effects of saturation. This tells us that we like the sound of saturation, but nothing at all about the summing. We need the control version to have passed through all the same analog circuits and DA/AD converters, but have been summed in the digital domain instead of in the summing mixer. In other words, as far as possible, we need to isolate the summing as the only variable. So far, I've yet to see a comparison that did this properly, so I've remained open-minded, but still too sceptical to consider investing in a summing mixer myself. Okay, that's the background. So when a friend of mine asked me to test a summing mixer he'd built, obviously I was intrigued to finally answer that question, at least to my own satisfaction. The unit in question is a prototype. It's not yet ready for publicity, and its creator has asked me to keep it a secret for now. But this is kind of ideal for my purposes. I can test the general concept of analog summing without worrying that I'm maligning any specific product or company. And if I conclude that it's all snake oil, I'm free to say so, without pissing on my friend's chips, as it were. The unit is also designed specifically to be clean and transparent. There are no transformers anywhere. The goal was to provide pure analog summing with no other side effects. Sure enough, my sine wave test tones made the round trip without any harmonics appearing on the analyzer, and my friend seems to have achieved this design goal admirably. And again, this is kind of ideal for my purposes, as it should make it easier to isolate the summing as the only meaningful difference in my tests. Anyway, I reused the mix from my omni-channel review to test it. I've grouped this down to 8 stereo pairs to feed 16 inputs of the summing mixer. Actually, that's only half the available inputs, but I can't do more than 16 outputs with my current setup, so that will have to do. I carefully calibrated every channel with test tones first, and tweaked the gain settings so that they were returning to the DAW at the same level, to within 1/10 of a dB, and bounced the mix with analog summing. That's what you're listening to now. Then I summed them all digitally instead, and bounced that stereo mix through channels 1 and 2 of the summing mixer. That's what you're hearing now. They do sound a bit different, right? So let's do a null test, which I did first in real life, if I'm honest. And there's quite a big difference. It would seem that the summing is indeed changing the sound in some way. However, notice those differences are just specific parts. There's no drums left, for example. That's all nulling out completely. So that suggests to me that actually this is just revealing my inability to match all the gains accurately enough. So I went back through and checked all the calibration, and sure enough, I had to make some slight changes. Either I didn't do it so well the first time, or they drifted slightly as the unit warmed up. Anyway, this time I took a slightly different approach. I soloed the first stereo pair and bounced them through channels 1 and 2 of the mixer on their own. Then I soloed the second pair and bounced those through channels 3 and 4 of the mixer, just as they'd been routed for the analog sum. And so on for all 8 pairs. And then, for good measure, having recalibrated the gains since the first one, I did another analog sum with all 8 pairs playing together. So what happens if I sum those 8 analogue pass-through stems digitally, then null that against the analogue sum? This time, it nulls down to the noise floor. That's a killer blow. If it nulls, it's the same. There's no point doing any listening tests. I've just proved that analogue summing makes no difference. Now, I realise that if you're already invested in analogue summing, this probably hasn't convinced you. And that's okay. I didn't really expect to change anyone's mind. I ran the test for my own curiosity and because my friend requested it. And I made the video purely for subs and ad revenue. Speaking of which, you are subscribed, right? Anyway, you're going to do it anyway, so I'll help you along with some reasons why you might want to disregard my findings. First of all, I can guarantee that as I'm testing an unreleased prototype unit, it's not the same one you dropped your hard-earned on. You can reassure yourself that while this particular unit might not add any magic, your specific unit definitely does, right? You've heard the difference, after all. It's not just cognitive bias messing with you, right? Speaking of cognitive bias, as hard as I tried to be objective and scientific, I did have a bias going in. While I tried to keep an open mind, I definitely leaned towards the view that analogue summing was just a big red herring going into the test. So I probably wanted that to be the outcome so that I could be proved right. And indeed, that bias probably increased as I prepared for the test. It hadn't occurred to me that summing out of the box might entail changing the way I mix. For example, I can't mix without a drum bus with compression on it. Well, I can, but I can't get to a mix that I'm happy with and sounds finished to me. And I did try to with this mix, with half a mind to this test. It just wasn't happening until I gave in and bussed all the drums through the channel strip compressor. So that means my drums will always get summed in the box regardless. Or I could do an initial analogue sum for the drums. Or I could use multiple summing boxes. None of those options really appeal to me at all. If I concluded that analogue summing was indeed some magic special ingredient, the only logical conclusion to that train of thought is I need a console. An analogue one, I mean. I've got a digital console. And I really don't want to buy an analogue console for a whole host of reasons. The initial expense, the ongoing maintenance, the electricity bill. I don't want to rearrange my setup to make room for one. And I don't want to screw up the acoustics of my room with one either. Yes, consoles can sound great, electronically speaking. Acoustically, not so much. So I had a whole bunch of reasons to want to get the result I got. And you can disregard my results on that basis if you like. I mean, I'd still say that you can't argue with my null test, but I would say that I'm biased. Next reason, my test setup was not particularly high-end. My usual interface only has 8 analog outs, and I don't have a DA converter handy to plug into the ADAT port, so I switched to using my X32 as an audio interface instead, using 16 XLR line outputs and returning to a pair of line-level aux inputs with no mic preamps. I would argue that the signals coming from my Behringer converters are just as analog as the ones coming from your Lavry or whatever, so any analog summing magic that may exist should still manifest. But feel free to write off my test due to affordable converters. And finally, 16 channels of balanced XLR to TRS cable actually represents a significant investment, and I'm way too cheap to spend that much just for this test. As a result, what I cobbled together is mostly unbalanced going to the summing mixer, and that's probably the reason the noise floor is higher than it should be. You could argue that there are significant differences buried in my noise floor that would suddenly manifest if I set this up properly. But while the noise floor is high for a digital mix, it's still perfectly acceptable and inaudible at normal listening levels. This is still less noise than you'd get recording to tape. So my next question would be, if the magic of analog summing is part of what made those classic records sound so good, how did that survive the noise floor of the tape if this noise floor I've got here kills it? But you probably have your fingers in your ears now and didn't hear the question. That's okay, I don't mind. You got to the end of the video and that's all I care about. Thanks for watching.